All right, let's dive right into this explainer. We're about to unpack a truly radical, but entirely rigorous mathematical premise. We're going to explore the framework that suggests our physical universe is fundamentally a number-theoretic information stream. Today, we're focusing directly on the equations and the specific mathematics that support all of this. So, get ready to look closely at the math. To guide us through these dense equations, we're going to follow a clear roadmap, starting with the architecture of logos theory, moving through the operator pipeline, deriving physical constants, geometry from large n limits, math shadows, and finally expanding to the strong force. Let's get right into it. Section 1. The architecture of logos theory. This overarching framework, the Adelic Langlands Program, is absolutely wild. It's a mathematical architecture so profound that it literally acts as the source code for what we call logos field theory. It completely merges continuous and discrete mathematics into a single unified computational engine. And it all operates in this elegant three-tiered stack. Think of it as a direct pipeline flowing upward. At the very bottom, we have the foundational engine of spectral projection filtering the raw data. That data then moves across what we call the J-theory bridge in the middle before finally outputting into the macroscopic manifestation of logos field theory at the top. That's where our physical laws actually operate. Moving on to Section 2, the operator mathematical pipeline. Now, this is where the mathematical gears really start turning. The Legendre UDD filter term, P sub lambda, is absolutely crucial because it explicitly cuts off chaotic, high-frequency quantum fluctuations using the Dirac operator squared. By filtering all that noise out, the valuation operator below it can map a stable, clean spectral density directly into the local places of the Adele ring. But wait, before we cross that J-theory bridge, we have to talk about where this is all actually happening. Because our fields, they aren't living in standard spacetime. No, they live on the Adele ring. This is a space built from rational numbers that processes quantum discrete logic, the Padic realms, and classical continuous space, the real numbers, at the exact same time. It is, literally, the ultimate unified base space. So the key player here is the semiclassical intertwining operator, I sub auto. Think of it as the mathematical translator. It takes those filtered quantum eigenvalues and integrates them over the full adelic quotient. In doing so, it mathematically forces the quantum eigenvalues of Cohn's spectral trace to perfectly match the Hecke eigenvalues of automorphic forms. It's a perfect mathematical handshake. All right, Section 3, deriving the physical constants. You might be wondering at this point, how exactly does purely abstract arithmetic trace data, like a Galois representation, actually cross over and become a physical invariant, like, say, physical gravity? Well, let's trace the explicit mapping chain. It starts with the arithmetic input of the absolute Galois group, denoted as rho. That moves through the Langlands lift to become an automorphic form, and then it undergoes Dirac localization to become a spectral density. Finally, right at the end of the chain, the Grothendieck-Riemann-Roch push-forward yields our physical effective action, G sub f, and that whole incredible width is spanned by the L function. Now, here's where it gets crazy. The math essential tells us that the entire quantization constraint of the physical vacuum hinges on one specific point, the critical pole at s equals 1. The residue of the Galois L function at this exact pole strictly dictates the asymptotic density of those Dirac eigenvalues through a generalized Weil law. And the math for the effective physical coupling constant shows that 1 over g effective squared equals beta times the L function at pole 1. This is huge. It proves that what we experience as perfectly stable physical constants like gravitational or gauge coupling are in reality just the semi-classical shadows of an underlying global arithmetic consistency, meaning if the arithmetic shifts, the physical constant shifts right along with it. Section 4, Geometry from Large N Limits. Let's stress test this math by scaling it to infinity. The J in J-theory? Yeah, it's not just some random letter. This single, bold J equation binds 3 vital components together to prevent the emergent spacetime metric from collapsing. You have the Jacobian fibers providing the geometric space, the elliptic J invariant pulling coefficients to ensure modular symmetry, and finally, the Donaldson-Uhlenbeck-Yau J stability holding the whole thing together. Within the Fourier-Mukai kernel integration, the Weil reciprocity law embedded in the exponent acts as an arithmetic wave function phase. And get this, it is strictly weighted by the dimensions of the monster group. We're talking numbers like 1, 744, and 196,884. This guarantees exact modular consistency during the entire transfer of information. So what happens as the rank of the gauge group, n, approaches infinity? Well, the scale factor n squared acts exactly like 1 over Planck's constant. We get this massive decompression collapse, where destructive interference cancels out most of the paths. The data stream is mathematically forced to localize. It has to perfectly follow the classical geodesic paths of the Gillet Soulé Arakelov metric, which is represented by G sub ij. Which brings us to Section 5, Math Shadows, Anomalies, and Defects. We have to ask, what happens when the arithmetic isn't perfectly smooth? The mathematical commutator reveals a stunning insight. A Hecke operator, T sub p, isn't just an abstract concept. When applied to the Dirac vacuum, the commutator doesn't vanish. Instead, it acts as an arithmetic time translation that actively pumps a discrete quantum of physical curvature, gravity basically, directly into the fabric of space. It becomes incredibly clear when we contrast the perfectly smooth, unramified prime numbers against the ramified primes where the arithmetic suddenly undergoes division. Smooth primes gracefully yield continuous geodesics and stable currents, but ramified primes, they mathematically birth localized topological defects. They physically tear into reality as cosmic strings and chiral anomalies. So those gauge anomalies, chiral breaks, or cosmic string defects we observe in physics, they are absolutely not structural failures of nature. Not at all. They are the exact, predictable mathematical shadows cast whenever an arithmetic prime factor undergoes division and ramifies in the absolute adele ring. Finally, Section 6, Expanding to Strong Force. Let's scale this up one last time to see how this handles atomic nuclei. By simply upgrading the matrix rank of the Galois representation from 2 to 3, going from GL2 to GL3, the mathematics natively generates a 3-sheeted spectral curve. This perfectly mirrors the 3 color charges of quarks. And the transitions between these sheets, they naturally yield the 8 geometric transition vectors, which correspond exactly to the 8 gluon fields of the strong nuclear force. It just falls right out of the math. We'll wrap up with the ultimate synthesis equation. It beautifully proves that what we perceive in the lab as physical momentum, gravitational refraction, and quantum scattering is really just the geometric translation of a continuous wave computing its way past a ramified prime factor. Which leaves us with a pretty profound question. Is particle physics simply applied number theory playing out on a cosmic scale? I hope this dive into the equations sparked your curiosity. Thanks for joining me.